So folks, after a quick review of logarithms, we're now ready in exponential statements. We're ready to solve some simple exponential and logarithmic equations here. So the key idea is that we have exponential statements, a to the m is equal to n, and those are equivalent to these logarithmic statements, log base a of n is equal to m. And the above statement allows us to rewrite any exponential equation. If we've isolated the exponential term, we can rewrite it as its equivalent logarithmic equation, or vice versa. If I see this equation here, I can move it here. This is really helpful if my variable is trapped in one of the arguments. So if my variable x is in the power of an exponential expression, I can help isolate the variable x by getting the power separated from the base by converting this to a logarithm. If that seems a little bit abstract, we'll do that in the next examples, so we'll make that a little more clear. But same thing, if my variable is here in the statement n, my letter x is somewhere in this large argument of the log base a, if it's trapped inside that logarithm, I can free it in a way. I can get the variable x separated from the logarithm if I rewrite it as the equivalent exponential statement. So oftentimes when we have an exponential equation, we'll convert it to a logarithmic equation, and oftentimes when we have a logarithmic equation, we'll convert it to an exponential equation. Let's put that into practice down below here. So here I've got this exponential equation, and the key step is, look, we've got this variable x that's trapped inside the power of this exponential statement. So the key step is to isolate the exponent, and then to rewrite it as a logarithm. Rewrite as a logarithmic equation. Let's see how that key step helps us out. So we've got 3 minus 2 to the power of 4x minus 5 is equal to 6, and I'm trying to solve this equation for the variable x. But right now, the variable x is trapped inside the power of this exponential statement. So let's go ahead and first isolate the exponential statement. So I'll first subtract over 3. And folks, I miscopied. This should be a minus 6 there. And so when I subtract over the 3, I'll get minus 9. Then I'll divide both sides by a negative 1, and that gives me this statement here. And look what we've done. We have now isolated the exponential expression. So we still have x trapped inside the power of the exponent. It's still trapped up there. But we've now isolated the exponential expression. This now looks like this statement right here. And here's the thing. What I'm trying to solve for is in the power of that exponential statement, and I can get the power separated from the rest of it if I rewrite it as its equivalent logarithmic equation. So let's give the equivalent logarithmic equation, which is that the log base 2 of 9 is equal to 4x minus 5. And now we can continue isolating the variable x. So if we add 5 over, we would have 5 plus the log base 2 of 9 is equal to 4x. And if we continue one step further, we would get that x is equal to 5 plus the log base 2 of 9, all divided by 4. And that's actually, that might look a little bit strange, but that's how we're going to park our answer. There's our solution to this problem. Now, one thing to keep in mind is that the domain of an exponential operation is all real numbers. And we aren't doing any other problematic operations here, so we can keep that solution. Okay, there's no trouble there. All right, so that was the first example. Again, there are times where I have a single exponent somehow trapped, a single variable x somehow trapped in the power of an exponent. The trick is first to isolate the exponent and then to rewrite the exponential expression as its equivalent logarithmic equation. There are other ways to think about this, folks. Sometimes instructors or helpers will talk about taking the log base 2 of both sides, and that's appropriate as well. That's another way to look at this. But I'd like, for the moment anyway, I'd like us to think about converting between one of these two forms. If this form isn't helping me, perhaps converting it to this form will, and vice versa. So let's put that into practice in this next example. So again, the key step is to isolate the logarithm. then rewrite as an exponential function. So let's give that a shot. We've got that the log base 6 of 4 minus 2x plus 8 is equal to 10. And we're trying to solve this for the variable x. But where is x? Currently, x is trapped inside this logarithm. And we're trying to isolate the variable x. So what can we do? Well, first we ought to do a little bit of rearranging. So I'll have the log base 6 of 4 minus 2x is equal to 2. Now I have isolated the logarithmic expression. This now looks like this key statement up here, which means if I wish, I can rewrite it as an exponential. And in fact, that's exactly what I want to do. I want to rewrite this as its equivalent exponential expression, which would be what? Well, the base of this logarithm is 6, and so for my exponential expression, we'll have 6 to the power of 2 is equal to 4 minus 2x, or 36 is equal to 4 minus 2x, and let's continue solving for x. So this would give me 32 is equal to negative 2x, or lastly, x is equal to negative 16. Now, this gives me an answer of x equals negative 16, and I'm not going to be a stickler for this in this class, but you should know that the domain of the log or the expressions is not all real numbers, so anytime you get a solution, you need to check your answer. If I were to plug negative 16 in for x back into the original equation, if we were to write log base 6 of 4 minus 2 times negative 16, all inside that logarithm, plus 8, and ask, does that equal 10? Well, we get the log base 6 of 4 plus 32 plus 8, and we're asking, does that equal 10? Which gives me the log, that should be a 32 there, folks. That would give me the log base 6 of 36 plus 8, and we're asking, does that equal 10? But the log base 6 of 36 is 2, and so, yes, it is. So we've checked that answer, and we can go ahead and give it as a solution. In this class, folks, maybe I ought to. I'm not going to trick you with that, where you solve an equation and you check it and it doesn't work. But you should be aware of whenever you solve an logarithmic expression that you should check your work. Okay, let's do 2 more examples. These 2 examples are basically identical to what we had above here. The first one's an exponential equation, just like so. And the second one is a logarithmic equation, just like we had. The only difference here is I want to make sure that you're getting comfortable writing in terms of base e. And remember, you can go back to the pre-work videos that discuss that, but at this point, if you just want to say, well, e is approximately the number 2.718, that helps you think about this as just any other exponential expression. It's just that e is such an important number that we call it out as we work these problems. Okay. So what's going to be my strategy here? We've got e to the 3x minus 1 plus 2 is equal to 7, and we're trying to solve for x. So just like before, what's our key step? To isolate the exponent and rewrite as a log equation. So here my exponent will be e to the 3x minus 1, so let's isolate it. When I do so, I get e to the 3x minus 1 is equal to 5. And now I can rewrite this exponential equation as its equivalent logarithmic equation. So don't write this down just yet, folks. You might think that we're going to write the log base e of 5 is equal to 3x minus 1, but that's not quite right because we don't write log base e. So let's go ahead and try that again. Instead of writing log base e, this is what we'll write. We'll write the natural log of 5 is equal to 3x minus 1, and now we can solve for x. By the way, folks, sometimes students have a hard time seeing this as a number. I want to convince you that this is just some value, and in fact, we could check that in a calculator. So I just want to convince you that this is just a value, so we can actually, from the calculator, it stores the value, the natural log of 5, and we check, and it's about 1.6, and that makes sense because e is about 2.7, and if I were to square 2.7, I'd have something bigger than 6. So the answer should be something in between 1 and 2, and sure enough, that's what we found. Okay. So even though this is an irrational number, just like you might have a square root of 2 or a square root of 3 in your answer, we're going to have a natural log of 5. So let's go ahead and isolate the x by adding 1 over to the other side. And at long last, I have isolated x, and we get x is equal to 1 plus the natural log of 5, all divided by 3. And that's how we'll give our answer. To that problem. We were solving an exponential equation. We have no problematic operations in here. I'm convinced that our answer works. Okay, let's look at the last question here. And in this one, we're going to solve an equation that has the natural log in it. So again, we're dealing with somehow, one way or the other, base e in these two problems. So let's give this a shot. In this problem, we started with an exponential equation. Our x was trapped in the power. We isolated the exponent, and we rewrote as a logarithmic equation. In this problem, we start with a logarithmic equation. We're going to isolate that logarithm, and then we're going to rewrite it as its equivalent exponent. Let's give that a shot. So we've got 5 minus the natural log of 1 minus x is equal to 3. Subtracting over that 5, lots of other things I could do, but subtracting over that 5 gives me minus 2. Dividing both sides by a negative 1, so both those terms have negative, I'm going to divide by negative 1. Why? Because I need to get this as a single isolated logarithm. That would give me the natural log of 1 minus x, and there we have isolated the logarithmic expression. So again, our strategy is that if x is trapped up here, we write it this way, and if x is trapped in here, we rewrite it this way. And so I'm going to rewrite this as its equivalent exponential expression. This is the logarithm, the natural logarithm, whose base is base e, and so we can write this as e squared is equal to 1 minus x. Isolating this, let's go ahead and add x over to the other side. Other ways you could do that, but I chose to add x over to this side. And as we get x by itself, we have x is equal to 1 minus e squared. What we ought to do is we ought to check our answer here. So if we plug this back into the original, we'd have 5 minus the natural log of parentheses 1 minus, and I'm going to plug in my solution in parentheses inside that logarithm for x. And this would give me 5 minus the natural log of, if we rewrote this, we would get 1 minus 1 plus e squared. Careful, that minus sign would get distributed. That's why I emphasize putting those parentheses there. Is equal to 3. And this would give me 5 minus 2 is equal to 3, because if I take the logarithm base e of 2, the natural log base e of 2, it just returns the power there. Lots of ways to explain that. If you're having trouble with that, please come by and see me. I'd be happy to explain why that's true. And we end up with 3 equals 3, so it checked. So our solution to this equation is 1 minus e squared. Notice, even though I'm not going to test you on this, it's a good habit that whenever you solve a logarithmic equation, you go ahead and check your answer, because you might have introduced extraneous solutions through these processes. Folks, we've gone ahead and solved that for x, and we've gotten some practice solving a handful of simple exponential and logarithmic equations. The basic idea is if you isolate an exponential expression, you can rewrite it this way as a logarithmic expression. And if you have a logarithmic expression, you can rewrite it this way as an exponential expression, and that might help you advance the problem forward as you try to isolate x. So folks, I'm going to leave you to work the remaining 4 problems on page 3 here. Some of them have solutions, some of them have answers. Go ahead and give those a shot. If you find that you're having difficulty with these, folks, please don't wait for me to find out. If you know you had difficulty with these problems, please come by and see me during office hours or stick around after class. I'd be happy to help you. Thank you very much. Bye-bye.